Next topic, we want to talk about the Intel architecture 32 processor architecture. So that's including the mode of operation and the basic execution environment and the floating point unit. Actually, that's a very big topic, so I don't want to spend too much time. We may not have so much time on Thursday, so I don't want to have too much video. So I just want to have the first video about the mode operation and to talk about here. So then the rest of that we will talk about in the Thursday video. So in Intel architecture 32, we have different mode operation. So the x86 processor has three primary mode of operation. They have protected mode, they have the real address mode, and the system management mode. So from what we see, most of the time we do the first two. The system management mode usually won't be direct access by the user. Instead, actually, it's operating system specific work on the system management mode. According to these three important modes, we also have a sub mode they call virtual 8086. That's a special case of the protected mode. So the first thing we see, what is protected mode? So the protected mode actually is the native state of the processor mode. For the Windows and Linux system, programs are given separate memory area. That's what we call segment. And the processor prevents program from reference memory outside the assigned segment. So actually protected mode is very important. After we have the protected mode, we start have the multiprocessor application. I know for you, you may not feel like multiprocessor mode. What's that talk about? I always can browse internet, look at the PowerPoint file, write my C++ code. I can open many different windows from my computer. However, before 90, it's impossible to do so. One computer actually have only one process mode. So actually if we want to work on the Word document, you only can do like this now. You cannot switch the windows unless you close your windows. So then you can start another one. So that's protected mode actually give us the benefit is because we allocate separate memory area, or we call the segment. So they won't interfere each other. Of course, who will control that? Right, operating system like earlier we told you. We have the descriptive table to make sure each memory slot, each memory segment only specific run from a program or application. They won't interfere each other. They won't take each other's memory. So since they can operate separately, so that's why you can have the processor prevent program from reference memory outside assigned segment. On the other hand, multiple applications can run fine at the same time. So that's the protected mode. Usually that's we use for now. And for the old Windows system, we have a DOS, Microsoft System DOS. That's what we call the real address mode. So this real address mode is implement the programming environment and very early Intel processor. So they have a few extra features like native MS-DOS system. They allowed you to switch into other mode. So that is useful if a program requires direct access to the system memory and hardware device. They kind of give you the flexibility to direct access the hardware device. Otherwise, the protected mode actually will be hide from the user. The user only can access application, but the user cannot direct to manage those memory. But the real address mode can do that. However, the real address mode later on we try to prevent to let user to direct access. So the benefit is we can prevent user interfere the memory directly. But the backward is the user cannot really make your computer hardware run more efficient. You only can rely on the application to update those information. So mostly user will see this too. So then the last one, the system management mode. They will provide an operating system with a mechanism for implementing functions such as the power management, system security, diagnostics, and implemented by computer manufacturer. So that's why you see here, this system management mode, you cannot access. On the other hand, remember now, you got the computer, you bought a computer, actually everything one piece. You just start on the computer, the operating system already on. That's because the manufacturer, for example, you may have the computer from HP, from IBM, from ASUS, from different manufacturers. Those manufacturers, they will direct to using the system management mode to deal with the hardware and to have their management, security, or how they will run the hardware analysis. So the computer manufacturer customize those processors for a particular system setup. So you have no way to do that. Sometime before, they maybe give you a backup CD. Now they even don't give you the backup CD. You maybe just have some USB, or they just right away have another partition to do the backup, or have your backup system. So that's have different mode operation for our x86. But you can see as a user, we only care the protected mode. So that can provide your multi application to run at the same time. So this protected mode, actually we have the other one is we call the virtual x8086. It is very similar to protected mode, but each program have its own 8086 machine. The processor can directly execute real address mode software. If the program crash, it won't affect other programs. So a modern operating system can execute multiple virtual 8086 sections at the same time. But you will see what's different between those protected mode or real address mode. So the most important thing is they will allocate different memory space for you guys. So then later we will see more. But here you just need to know, in this video, we just need to know what kind of the operation we have from the x86. So later on, when we talk about more about the execution environment, so then we will reflect back how to see the memory access from those different modes.